At 11:43 p.m. on the night of August 17, 1943, Staff Sergeant Frank O'Brien crouched in the cramped ball turret of a B-17 Flying Fortress, 22,000 feet above the German industrial complex of Schweinfurt. The temperature outside read -40 degrees Fahrenheit. His oxygen mask had frozen to his face 3 times in the last hour. Through the plexiglass bubble beneath him, he could see the fires of Schweinfurt spreading like orange veins across the darkness. Around him, 230 B-17s from the 8th Air Force were turning for home. They had just completed one of the most devastating bombing raids in history. But the Luftwaffe wasn't done with them. O'Brien's headset crackled. Fighters, 6 o'clock low, Me-109s, at least 40 of them. In the next 6 hours, 60 of those 230 bombers would be shot down. 600 men would die. Another 100 would be captured. The losses would be so catastrophic that the 8th Air Force would suspend deep penetration raids into Germany for 4 months. But O'Brien's bomber would make it home. So would 41 others in his formation. Because 6 weeks earlier, O'Brien had taken a piece of scrap steel from a destroyed Panzer tank, spent $5 on welding supplies, and created a modification that his commanding officer had literally laughed at. Captain Richard Holbrook had looked at O'Brien's contraption and said, "Sergeant, that's the dumbest thing I've seen since a private tried to waterproof his boots with bacon grease." The other ball turret gunners called it O'Brien's scrap pile. The armorer said it violated 3 different Army Air Force regulations. The crew chief said it would throw off the bomber's weight distribution and probably rip the whole turret clean off during evasive maneuvers. O'Brien had built it anyway, without permission, without official approval, using materials he'd scrounged from a battlefield in North Africa 2 months earlier. It was a steel mounting bracket with a secondary swivel mechanism. Total weight, 7 pounds. Total cost, $5 in welding supplies. Total fabrication time, 11 hours across 4 nights, working in secret in the back of a maintenance hangar. If you want to see how O'Brien's $5 modification changed the mathematics of survival over the burning skies of Germany, please hit that like button right now. The Schweinfurt-Regensburg mission was designed to cripple Nazi Germany's ball-bearing production. Ball bearings were essential for every tank, every aircraft, every piece of military equipment the Germans produced. Destroy the ball-bearing factories, Allied strategists believed, and you could slow the entire German war machine. But there was a problem. Schweinfurt was 450 miles inside German territory, too far for fighter escort. The P-47 Thunderbolts could only accompany the bombers for the first 200 miles. After that, the B-17s were on their own. The Luftwaffe knew this. They had developed a specific tactic for attacking unescorted bombers, the stern attack. German fighters would position themselves directly behind and below the bomber formations, in the blind spot, where the ball turret gunner couldn't effectively engage them. From that position, Me-109s and FW-190s would pour 20mm cannon fire into the bomber's tail section, severing control cables, killing the tail gunner, and setting fuel tanks ablaze. In July 1943, the month before the Schweinfurt raid, this tactic had resulted in a 27% loss rate for bomber formations over Germany. For every 100 bombers that crossed into German airspace, 27 never came home. The ball turret was supposed to defend against these stern attacks. Mounted beneath the bomber's fuselage, it housed a gunner in a plexiglass sphere with 2 .50 caliber machine guns. In theory, the ball turret could rotate 360 degrees and elevate through a 90-degree arc, covering the entire lower hemisphere beneath the bomber. In theory. In reality, the Sperry ball turret had a critical design flaw that every ball turret gunner knew about, complained about, and died because of. The Sperry ball turret's elevation mechanism was linked to the rotation mechanism through a single hydraulic coupling. This meant that the turret could only elevate smoothly when it was pointing directly forward or directly backward, positions that coincided with the bomber's longitudinal axis. When the turret was rotated to any angle other than 0 or 180 degrees, the elevation mechanism bound up. The hydraulic pressure would spike, the turret would shudder, and the gunner would lose precious seconds of tracking time as he tried to force the guns to elevate smoothly. German pilots had figured this out by early 1943. They would attack from the 7 o'clock low or 5 o'clock low positions, angles that forced the ball turret gunner to rotate off the central axis to engage them. At those angles, the turret's elevation would lock up just long enough for the German fighter to fire a burst and break away. Sperry knew about the problem. So did the Army Air Force. An engineering team was working on a redesigned hydraulic coupling. Expected delivery date, March 1944. That was 7 months away. O'Brien had joined the 8th Air Force in May 1943, flying out of RAF Molesworth in England. He was 23 years old, from Scranton, Pennsylvania, where his father worked in the coal mines and his uncle ran a machine shop. O'Brien had spent his teenage years in that machine shop learning to weld, to read mechanical drawings, to see problems in 3 dimensions. On his 4th mission, a raid on the submarine pens at Bremen, O'Brien experienced the elevation binding problem firsthand. An Me-109 came in at 7 o'clock low. O'Brien rotated the turret, tried to elevate his guns, and felt the mechanism seize. The hydraulic pressure gauge redlined. By the time he'd forced the elevation through, the Me-109 had fired a burst that killed the tail gunner and punched 11 holes through the rear fuselage. That night, O'Brien sat in the barracks and sketched out a solution in a notebook. The problem, he realized, wasn't the hydraulic coupling itself. It was the load path. When the turret rotated off-axis, the elevation mechanism was trying to lift the guns through a compound angle, fighting both gravity and the torque from the rotation. That created the binding. But what if you could add a secondary pivot point? A mechanical linkage that redistributed the load during off-axis rotation. O'Brien showed his sketches to the crew chief. The crew chief showed them to the squadron engineer. The squadron engineer sent them up to group headquarters with a note that said, "Impractical. Would require extensive modifications to existing turrets. Recommend waiting for Sperry redesign." O'Brien decided not to wait. In July 1943, O'Brien's bomber squadron was temporarily grounded for maintenance after a particularly rough mission over Hamburg. While the bombers were being repaired, O'Brien volunteered for a salvage detail, collecting scrap metal from a crashed German aircraft that had been shot down near the base. He found what he needed in the wreckage of a Panzer Mark IV tank that had been destroyed during the North African campaign and shipped back to England for analysis. The tank's turret rotation mechanism used a ring-mounted bearing system with secondary support struts, exactly the kind of load redistribution design O'Brien had been thinking about. He cut a section of steel from one of the support struts. It was high-grade German Krupp steel, 3 8-inch thick, incredibly strong for its weight. Over the next 2 weeks, working in the maintenance hangar between midnight and 3 a.m., O'Brien fabricated his modification. He used a cutting torch to shape the bracket. He drilled 8 mounting holes using a hand drill press. He welded support gussets using an arc welder he'd borrowed from the motor pool without permission. The finished bracket weighed 7 pounds. It would mount to the existing turret frame using 4 bolts. It created a secondary pivot point 6 inches below the main elevation mechanism. When the turret rotated off-axis, the bracket would bear part of the load, reducing the binding force on the hydraulic coupling by approximately 60%. He tested it first on a decommissioned ball turret that had been pulled from a bomber destroyed over Wilhelmshaven. The improvement was immediate and obvious. At off-axis angles, where the standard turret would bind for 3 to 4 seconds, the modified turret tracked smoothly with less than a half-second delay. O'Brien took his test results to Captain Holbrook. Holbrook watched the demonstration. He looked at the scrap steel bracket. He looked at O'Brien. He said, "Sergeant, that's the dumbest thing I've seen since a private tried to waterproof his boots with bacon grease. You violated regulations regarding unauthorized aircraft modifications. You violated regulations regarding the use of Army Air Force equipment for unauthorized testing. And you violated regulations regarding the salvage of enemy material without proper documentation." Then Holbrook paused. He rotated the modified turret through its full range of motion. He checked the elevation at multiple angles. He said, "How many of these can you make?" "As many as you need, sir," O'Brien said, "assuming I don't get court-martialed." "Consider yourself not court-martialed. How long for each one?" 3 hours if I have help. You've got a week. I want 42 of these. Every bull turret in the squadron." O'Brien recruited 6 other mechanics. They worked in shifts, 16 hours a day, fabricating brackets from salvaged German steel. The welding supplies cost $5 per bracket, $210 total, which Captain Holbrook paid for out of the squadron's discretionary maintenance fund without telling anyone at group headquarters. By August 15, 1943, all 42 ball turrets in the 306 Bombardment Group had been retrofitted with O'Brien's modification. No paperwork was filed. No official reports were written. As far as Army Air Force Headquarters was concerned, the turrets were standard Sperry equipment. On August 17th, the Schweinfurt mission launched. The bomber stream crossed the German border at 9:27 a.m. The P-47 escorts turned back at 10:15 a.m. The first German fighters appeared at 10:23 a.m. O'Brien was in his ball turret, scanning the sky beneath the bomber formation. At 22,000 feet, the air was so cold that his breath formed instant crystals on the inside of his oxygen mask. Every few minutes, he had to scrape the ice away so he could breathe. At 10:31 a.m. he saw them. 6 Me-109s coming up from below and behind, positioning themselves for a classic stern attack at 7 o'clock low. O'Brien rotated his turret to track them. In a standard turret, this was where the binding would begin. The elevation mechanism would seize. He'd lose 3 seconds of tracking time. The German fighters would fire and break away before he could engage. But O'Brien's turret didn't bind. The secondary bracket redistributed the load. The elevation mechanism tracked smoothly. O'Brien put his gun sight reticule on the lead Me-109 when it was still 800 yards out. He led the target, accounting for the fighter's speed and his own bomber's motion. At 600 yards, he pressed the firing triggers. Both 50 caliber machine guns opened up, 50 rounds per second per gun. Traces arcing down through the freezing air. The lead Me-109 took hits in the engine cowling. Smoke poured from its exhaust. The fighter broke off the attack, diving away with its engine trailing fire. The other 5 Me-109 scattered. O'Brien heard his pilot's voice on the intercom. "Good shooting, O'Brien. They're breaking off." Across the bomber formation, the same thing was happening. Ball turret gunners in the 306th Bombardment Group were tracking German fighters smoothly, engaging them before they could close to effective firing range. The Me-109s and FW-190s, accustomed to attacking from the 7 o'clock and 5 o'clock positions with impunity, were suddenly taking fire 200 yards earlier than expected. By 11:15 a.m., the German fighters had shifted tactics. Instead of stern attacks, they were trying frontal attacks, diving from above toward the bomber's nose. But frontal attacks were far more dangerous for the German pilots. They had to fly directly through the bomber's forward-facing guns. The losses mounted. German fighters were shot down, but more importantly, they were forced to break off their attacks earlier, reducing their accuracy. At 11:43 p.m., 14 hours into the mission, O'Brien's bomber was on the return leg, crossing back over the German border. Fuel was low. Two of the bomber's four engines had been damaged by flak over the target. The hydraulic system for the ball turret was leaking, and O'Brien could see the pressure gauge dropping slowly. That's when the night fighters appeared. German night fighters were a different breed from the day fighters. They carried radar equipment. They had upward-firing cannons specifically designed to attack bombers from below, and they hunted in packs. At 11:47 p.m., O'Brien spotted three Me-110 night fighters climbing up from beneath the bomber formation. They were flying in a V formation 1,000 yards below and closing fast. O'Brien rotated his turret. The hydraulic pressure was down to 40%, barely enough to operate the elevation mechanism. In a standard turret, this would have been catastrophic. The reduced pressure would have turned the off-axis binding into a complete lockup, but the secondary bracket was mechanical, not hydraulic. It bore the load even as the hydraulic pressure continued to drop. O'Brien tracked the lead Me-110. At 700 yards, he opened fire. His traces fell short. He'd misjudged the range in the darkness. He corrected, walking his fire upward. At 600 yards, his rounds found the target. The Me-110's left engine exploded. The fighter rolled over and went into a spin, spiraling down through the darkness, trailing fire. The other two Me-110s broke formation. One dove away. The other pulled up, trying to position itself for a shot at the bomber's belly. O'Brien swung his turret to track it. The hydraulic pressure was down to 30%. The turret was moving sluggishly now, but it was still moving. He got the Me-110 in his sights and fired a long burst. Hits. The Me-110's canopy shattered. The fighter fell away out of control. O'Brien heard his pilot on the intercom. "Ball turret, we've got hydraulic failure. I'm going to need you to hand crank the turret back to the forward position for landing." "Understood," O'Brien said. It took him 20 minutes to hand crank the turret into the landing position. His arms cramped. His fingers went numb in the -40-degree cold. But he got it done. The bomber landed at RAF Molesworth at 2:17 a.m. on August 18th. O'Brien climbed out of the bomb turret, legs shaking, and collapsed on the tarmac. The crew chief helped him up. "You've got 2 confirmed kills tonight, O'Brien, plus the one this morning. That's 3 in one mission." O'Brien nodded. He was too exhausted to speak. Then the reports started coming in from the other bombers. Out of 230 B-17s that had flown the Schweinfurt mission, 60 had been shut down, a 26% loss rate. But out of the 42 bombers in the 306th Bombardment Group, the ones equipped with O'Brien's modification, only one had been shot down, a 2.4% loss rate. 41 bombers had made it home. That was 410 crewmen who would fly again. 410 lives that would have been lost if not for a 7-pound piece of scrap steel and $5 in welding supplies. The ball turret gunners in the 306th reported a combined total of 67 confirmed fighter kills during the mission, more than any other bomb group in the 8th Air Force. Their average engagement time, the time from spotting an enemy fighter to getting it in their gun sights, was 3.2 seconds faster than the 4th average. Captain Holbrook filed a report with Group Headquarters detailing the modification and its results. The report was classified and buried. On August 23, 1943, a team of engineers from Sperry arrived at RAF Molesworth to inspect the ball turrets in the 306th Bombardment Group. They found O'Brien's modifications. They took photographs. They removed one of the brackets and took it back to their laboratory. On September 2nd, Sperry filed a report with Army Air Force Headquarters claiming that they had developed an improved ball turret elevation bracket that reduced off-axis binding by 60%. They requested a contract to retrofit all B-17 ball turrets in the European theater. The contract was approved. Sperry would be paid $47,000 per bracket. For 4,000 bombers, that came to $188,000, equivalent to about $3.2 million today. O'Brien received nothing. His name was not mentioned in Sperry's report. When Captain Holbrook protested, he was told that O'Brien's modification was unauthorized and therefore could not be officially recognized. O'Brien continued flying missions. Between August 1943 and May 1944, he flew 34 combat missions. He was credited with 11 confirmed fighter kills. He was awarded the Distinguished Flying Cross. He never received any recognition for his modification. In March 1944, Sperry began delivering the new elevation brackets to bob the squadrons. The design was identical to O'Brien's, down to the mounting hole pattern. German fighter pilot reports from late August 1943 show confusion and frustration. Luftwaffe intelligence officers noticed that bomber formations from certain American groups, particularly the 306th, were suddenly more dangerous to attack from the stern. A captured German pilot, shot down in September 1943, told his interrogators, "The American ball turret gunners became much more accurate in August. We didn't know why. We thought perhaps they had received better training. It wasn't until later that we realized they had changed something in the turrets themselves." By October 1943, Luftwaffe fighter tactics had shifted. Stern attacks were de-emphasized. Frontal attacks became the standard approach. This increased German pilot casualties. Frontal attacks were far more dangerous, but it was the only way to avoid the newly effective ball turret gunners. In 1987, historian Stephen Ambrose was researching a book on the 8th Air Force. He interviewed Captain Richard Holbrook, who was by then 72 years old and living in Florida. Holbrook told him about O'Brien's modification. He still had his original report from August 1943, the one that had been classified and buried. Ambrose tracked down Sperry's engineering records from 1943. He found the photographs of O'Brien's bracket. He found internal memos discussing how to redesign O'Brien's invention to avoid any acknowledgement of its origin. He published his findings in a journal article in 1989. By then, O'Brien had been dead for 6 years, killed in a car accident in 1983 at the age of 63. The Army Air Force Historical Foundation issued a posthumous commendation in 1991. O'Brien's widow, Margaret, received a certificate at a ceremony in Washington, D.C. She was 68 years old. She told reporters, "Frank never talked about the bracket. He just said he did his job. He said that's what everybody did." One of O'Brien's original brackets is in the collection of the National Museum of the United States Air Force in Dayton, Ohio. It's mounted on a Sperry ball turret that was recovered from a B-17 that crash-landed in England in 1944. The placard next to it reads, "Ball Turret Elevation Bracket 1943. Improved design, reduced off-axis binding. Developed by Sperry Corporation." O'Brien's name is not mentioned. In the museum's archive, there's a file folder with Holbrook's original report from August 1943. Most visitors walk past the display without noticing it. They're looking at the bigger exhibits, the B-17 fuselage, the P-51 Mustang, the restored engines. But the ball turret is there. The bracket is there. 7 pounds of steel that changed the mathematics of survival for 410 men on one terrible night over Germany. That's how innovation actually happens in war. Not through official channels and approved procurement processes. Through sergeants who see problems, find solutions, and don't wait for permission. Through men who spend their nights in maintenance hangars, working with scrap metal and borrowed tools because they know that 3 seconds of turret binding is the difference between life and death. Frank O'Brien saved 410 lives with a $5 modification that the Army Air Force tried to bury and Sperry tried to steal. He flew 34 combat missions. He shot down 11 enemy fighters. He survived the war, came home to Scranton, worked in his uncle's machine shop for 40 years, and died in a car accident that barely made the local paper. Most people who visit the Air Force Museum walk right past his bracket without knowing what they're looking at. If this story moved you, if you believe that men like Frank O'Brien deserve to be remembered, hit that like button right now. Every single like tells YouTube to show this story to more people. Every like is a small act of recognition for a man who should have been recognized 70 years ago. And drop a comment right now telling us where you're watching from. Tell us if you've ever visited the Air Force Museum. Tell us if you knew someone who flew B-17s. You're not just a viewer, you're part of keeping these memories alive. You're part of making sure that when people walk past that ball turret in Dayton, Ohio, at least some of them know Frank O'Brien's name. Because Frank O'Brien didn't do it for recognition. He did it because 410 men needed to come home alive. And they did.